Hello and welcome to Graphs of Factorized Cubic Functions. We're extending what we've already looked at about cubic graphical formations and looking at what graphs look like when they're not in our standard graphical form and they're in any of the other types of cubic forms that they could come in. So what we already know, which is on your screen, is that a cubic is a monomial, a binomial, a trinomial, or a polynomial with a leading term of x cubed and therefore a degree of 3. Cubics have the general shape of a lightning bolt when they're graphed, although this can change quite a bit depending on the actual function, but they will still have that general shape. Cubics can be in any of the following forms. We can have the factored form, which is our 3 x-intercept values, each in its own set of brackets. We can have a linear equation multiplied by a quadratic equation, which is x by x squared, which of course makes x cubed. We can have our standard cubic form, which is a x cubed plus b x squared plus cx plus d, where d is our constant. The simple form, y equals x cubed, and as we know, the graphical form, a outside of x minus h cubed plus k. Cubics can have 1 x-intercept, 2 x-intercepts, or 3 x-intercepts, but not none and not 4 or more. So if we continue to have a look, we can see that any of them can be graphed, obviously, and here is our example. The example is the factored form x minus 1 times x plus 2 times x plus 1 equals 0. So we have our 3 x-intercepts, which are quite clearly stated there. We can see that the x-intercepts are at x equals 1, x equals negative 2, and x equals negative 1. And if I was to go ahead and replace all of those x values in that function with a 0, we would find our y-intercept, which in this case would be negative 2. So if we actually graph that and have a look, we can see that, as expected, x minus 1, x plus 2, x plus 1 has 3 x-intercepts, 1 at negative 2, 1 at negative 1, 1 at positive 1, as we expected, and a y-intercept at negative 2, which we also expected. If we continue to look at our example now, we can see that if I multiply two of those sets of brackets, I end up with a quadratic equation. And if I multiply that quadratic equation by the remaining set of brackets, I have the linear biquadratic format of a cubic function, which I've done here at number 2. I'm left with x plus 1 multiplied by x squared plus x take 2. So that's our linear function multiplied by our quadratic. If I go ahead and graph it in this format, we will see that it is exactly the same. So the blue line there has completely overlapped the red line, and that proves that they are indeed the exact same cubic. Let's go back to our example. And if I multiply my linear function by that quadratic function, I end up with my standard format of a cubic, which I have here at number 3. X cubed plus 2x squared take x take 2, which, if I graph that, is also exactly the same. All three functions completely overlap each other because they are different versions of the same function. The factorized version, the linear biquadratic version, and the standard cubic version. Because the leading coefficient is a positive number, it's positive 1, that means that the graph has our general positive shape. If that leading coefficient happened to be a negative number, that's what would make it a negative shaped graph. And that is everything you need to know so far about graphs of factorized cubic functions.